Hi, my name is Ben Stevens, and today I'll be giving you a brief overview of an inquiry project I recently took with one of my Year 8 Science classes. The title of my investigation is The Effect of Group-Based Games on the Learning of Students in a Junior Science Classroom. As you'll read here, numerous studies have shown that group-based learning and games in the classroom can enhance learning. In my study, I've combined those two ideas to determine what effect group-based games will have on the academic progress of a class across a whole unit of study. To do this, a unit of study has been run where the majority of learning activities were group-based games. The summative assessment marks from this unit and another unit where a more traditional teaching approach was used have been compared. The results from this comparison show that 2/3 of the class improved their marks with an average improvement of 29%, and 1/3 of the class saw a decline in their marks with an average decline of 24%. As a class, there was an average improvement of 11%. The students that did decline were generally either high achievers or low achievers, whilst those that did improve were usually average achievers. This, an observation of the individual students, leads to a conclusion that perhaps the success of group-based games in this class was determined more by the sociability of the student rather than prior academic performance. The rationale behind this intervention is threefold, as you can read here. This results in the clear conclusion that a new approach to teaching chemistry, the focus area of study, was needed. From observations and student feedback, a group-based and game-centered unit may address behavioral focus engagement issues. The literature, which I'll discuss in the next slide, indicates that group-based games may be effective in the teaching of difficult concepts as well. Piaget's stages of cognitive development indicate that abstract thinking does not truly occur until the final stage of development, the formal operational stage. This stage usually occurs from around 12 years of age, which is very close to the age of the students in this junior science classroom. However, studies have also shown that 25% of adolescents only 25% of adolescents may be in this stage. As such, abstract thinking will be a difficult concept for many students in this class. This may explain why students have not traditionally performed well in the abstract, idea-heavy chemistry unit of the Victorian curriculum. Lev Vygotsky's theories on the zone of proximal development, ZPD, and the knowledgeable other provide one avenue for how this difficulty might be overcome. Whilst the teacher aims to be the first knowledgeable other for students, working with them to have them work within their ZPD, students' peers can also work as the knowledgeable other. Through the use of peers, students may be able to tackle more difficult concepts and learn at a greater rate, thus addressing the implications from the Piagetian studies that abstract thinking may be beyond the capability of most students. Following on from this, I've also included 4 of the studies that are representative of the research I've conducted. These studies illustrate why group-based games might be an effective tool to build on Vygotsky's theories and address the concerns raised by the Piagetian literature. As illustrated by these studies, a reasonable conclusion is that group-based games and game-centered learning would likely help junior science students to better learn complex ideas, and abstract ones too. This is the foundation for my study, and I'll next discuss how I went about doing this. I would just like to touch on here what sort of games and activities were used in the unit of study. Over the course of 4 weeks, each lesson featured at least one group-based game or group-based puzzle. Examples of these shown on the slide are flashcard games, bingo, Pictionary, and practical challenges. From the assessment side of things, I relied heavily on Kahoot and pub quiz style games to diagnostically and formatively assess the growth of the students. As I'll soon discuss, the summative assessment was a key part of the analysis, and this was also game-based, with puzzle-style tests. The data collected in this inquiry has been collected from individual students. However, it is the whole class growth that is the main point of interest in the study. As such, individual student data has been collated and analysed to determine whole class statistics at each stage of the inquiry. There's been minimal focus on selected individuals within the class, even as case studies that exemplify different levels of ability within the class. To determine the effectiveness of games within the junior science classroom, data was collected at various stages throughout the inquiry, and also from prior to the inquiry period. As shown on this slide, I divided the data into a few sections. The main data that I'm going to discuss here is the historical data and the summative data, as this is the data I've used to determine if the study was successful. To assess the historical academic performance of the class, I collected the summative assessment marks from this area's study and analysed it to determine the average, minimum, maximum, standard deviation, and median marks for the class. I also did this for the focus area study and then compared the 2 sets of summary statistics. The method of content delivery and assessment for the inquiry unit of study could be deemed successful if the results showed that the class as a whole had achieved growth at similar or greater levels to the prior areas of study. All of the summary statistics were important in reaching this conclusion, as a decline in any one of the statistics may indicate that one or more students in the class had not learnt as well from the learning activities as they had from previously units of study. A number of pieces of data have been displayed here on this slide, as they illustrate the data well. I'll go through each of these now. Firstly, have a look at Figure 1. This figure illustrates or shows that the summary statistics for the class for Topic 1 and Topic 2, summative assessments. These summary statistics indicate that overall the class improved when games were used to teach. However, the minimum mark did drop by almost 20%, and the class results did spread out further, as indicated by an 18% increase in the standard deviation. Figure 2 allows us to delve deeper into the class data and better understand the positive and negative growth in the class. As this figure shows, 2/3 of the class saw an improvement in marks, with an average improvement of 29%. In opposition to this, though, is the fact that 1/3 of the class saw a decline in marks, with an average decline of 24%. Although it is not shown in this figure, both the improvement in marks and the decline in marks were approaching normal distributions. Yet, due to the low number of students, this cannot conclusively be determined. All of this indicates that for every 2 students that saw an improvement of marks, there was 1 student who saw a decline in marks that was roughly equivalent to the average improvement of the other 2 students. Figure 3 and 4 help to illustrate this trend further. Figure 3 indicates that when looking at the class as a whole, it performs better with students who originally scored as low, medium and high, generally pushing their mark higher, and many pushing their mark to very high. Figure 4, however, indicates that Figure 3 is deceiving, and in fact improvement and decline happened at all levels in the class. In general though, it is the highest performing students and the lowest performing students in the class that see a decline in marks. The students who occupy the average mark group in the Topic 1 summative assessment all see an improvement marks but one. This outlier student had been experiencing many social problems at the time of the test and was not concerned in completing it to a high standard. From the results, the following conclusions can be made. Games in the junior science classroom are effective for the majority of students, but also ineffective for some. The improvement or decline is similar in absolute magnitude and might be considered to be approaching a normal distribution. Thus, the improvement and decline in marks is likely due to a normally distributed attribute. Students who see a decline in marks may mostly be outside of the average range. From observations and qualitative data, these are the students that struggle socially. Communication and interaction skills are also a normally distributed behaviour. As the unit features many group-based games, these observations indicate that a reasonable conclusion could be that students saw an improvement depending on how well they could relate to their peers. It is likely that the highest performing students and the lowest performing students were unengaged by the games in the class and/or did not find their peers to be accessible, knowledgeable others. Speaking with the students who did not perform well, this was indeed the case. The highest performing students felt the games to be a waste of time and did not enjoy working in groups. The lowest performing students enjoyed the games, but found that they were also able to rely on their peers to answer all their questions for them. Thus, they weren't using them as knowledgeable others. The study has shown that games in the junior science classroom are an effective tool to help the majority of students improve their marks. This is particularly true for students who lie in the average range. Some students, though, saw a decline in marks over the course of the unit of study, and this was likely due to less engagement in the games. So to follow up on this student study, further studies should be undertaken to further establish the relationship between engagement/interaction and the effectiveness of group-based games on the learning of individuals rather than as a group. In particular, the effectiveness of games on traditionally high-performing students should also be confirmed and studied further. Other studies could also determine if non-group-based games might be effective for learners, particularly those that did not benefit from the group-based games that were the focus of this study. To summarise, the reasonable actions that can be taken from this research are: group-based games can be used in the classroom, but should be accompanied by other activities. Students who traditionally perform well and perform poorly in the focus class may need support and/or alternative activities when games are played. Thank you.